we want to calculate tangent beta. Okay. So tangent beta right? Tangent beta is equal to FC over NC, right? So FC is FP sine alpha plus by FQ cos alpha divide by FP cos alpha minus by FQ sine alpha. Okay. So you divide the top and denominator by cosine. Okay. So this will be equal to FP tangent alpha plus by FQ, right? Then you divide by FP minus by FQ tangent alpha. So what I did is I just divide the top by cosine alpha and the bottom by cosine alpha. So from here, you can find your friction angle or the ratio of FC over NC. Okay, that is what we call the ratio of FC over NC, right? So this is to count. So with this value, you can calculate the with this value over here, you can calculate FC, the shear stresses acting on the tool. Okay, and NC, you can calculate the normal stresses acting on the tool. Okay, so the next one that I want to relate to you is how to calculate. So the tool is important. The next one is what's happening on the shear plane. Okay, what's happening on the primary shear zone or primary shear plane. So the math is not difficult, right? It's all vectors, and you have to know, you have to identify when is it positive and when is it negative. So over here, you are going to determine the stresses acting on the shear plane. Okay. Now in the homework or in the assignment, I there's a question on it and I show you how to solve it. Okay, it's exactly the same like what I'm doing with you now. Only I show you how to calculate the stresses on the shear plane. Okay. So now we are going to relate Fs Ns okay in terms of Fp, Fq, and pi. Okay. Right. So down here we know Fp. Down here we know FQ. I've not taught you how to find the shear angle first. Okay. So that's where we will do it experimentally, and then I'll show you how to predict. Okay. So let's look at Fp. Okay. So Fp is again in this direction. Then we have our shear. Okay. So this is our Fs1 and this is our Ns1 and this is affected by our shear angle. Okay. So you can see that Fs1, okay, so Fs1 and this is 90 degrees. Right. So Fs1 is equal to Fp cos pi, right? And we know that this is positive, the direction is the same. And Ns1 is equal to Fp sine pi. It's also positive because it's the same direction with Ns in our diagram. Okay. Then next, we're going to determine the Fs2, Ns2 contributed by Fq. Okay. So this is our Fq. And then this is over here, right? This is our shear angle. Right, so if that is our shear angle, right, so this will be our FS2 and this will be our NS2, and this is 90 degrees, and for this case, this is our shear angle over here. Okay, so FS2 is equal to FQ, right, sine pi, right? So FS2 and FS are in the same different direction, so this will become what? Minus, right? So next in is NS2 is equal to FQ cos pi, and NS2 and NS is in the same direction, so it becomes what? Positive. Okay, so now we can calculate the summation of Fs, right? So summation of Fs is Fp cos pi, right? Then minus by Fq sine pi, okay? And then Ns, so this will be equal to Fp sine pi, right? So NS2 is plus by FQ cos pi, okay? So this angle over here, so there's another angle that we can relate Fs to NS2, okay? So we are going to look at this whole angle over here, okay? So we're going to look at this angle. Okay, so this angle over here is pi plus by beta minus alpha, okay? Because that angle relates Fs and Ns, okay? So if we do a tangent, okay? If we do a tangent, right? Pi plus by beta minus alpha. So this will be equal to Ns over Fs, okay? So we know that Ns is Fp sine pi, right? Plus by Fq cos pi. And then the whole thing divided by Fp cos pi, right? Minus by Fq sine pi, right? Then all this you divide by cosine pi. So it's Fp tangent pi plus by Fq divide by Fp minus by Fq tangent pi. Okay. So now all this is good and hunky-dory. The question now is how to determine pi, right? So I'm going to teach you how to determine pi experimentally first. And then we are going to use an analytical model. Then we will end our lecture, okay? Right, so the shear angle critical, okay? So the shear angle pi okay, the shear angle pi is determined by measuring the deformed chip thickness. Okay. Okay. So I'm going to draw the tool now. Okay, we're going to draw the tool. So this is our tool. All right. Then we have straight line across here, right? So these two over here, the vertical orientation over here, this is our pi. Okay. Then we have our shear plane. Okay, so this is our too steep. Okay, so this is our shear angle. So this is our small t, right? And then we go up this way, right? So this will form a 90 degrees angle from here. So this distance from here to here is big T, right? So we know that we have defined cutting ratio. That is small r is equal to small t over big T, right? We did this last week, okay? So we also know, right, that this angle over here, okay, you guys derive it later on, okay, is pi minus alpha. Okay, so that is the angle over here. Now, big T is a process parameter. So you decided what it is. This is measured. Okay. Right. So we also know that big T will always be greater than small t, and R is always less than what? 1. We wrote this last week. Oh, yeah. Okay. So over here, this is my point A. And over here, this is my point B. Okay. So LAB is the length of the shear plane. Okay. Because we know the angles, we can relate LAB to small t and big T. Okay. So what do I mean by that? So psi pi, right? Psi pi is equal to small t divided by what? LAB. Right? That is our small t. So the next one is cos pi minus alpha, right? Pi minus alpha is equal to big T divided by LAB. Right? So we have this relationship, right? So we can equate with LAB, right? So we can rewrite equation. I'm going to call this equation 1 and equation 2. So we're going to use both equation 1 and 2. Okay, we're going to use both equation 1 and 2. So we know that LAB, right? Both the common term is LAB. So T over sine pi is equal to big T divided by cos pi minus alpha. Okay. So what we want to find down here is pi. Okay, we want to find, sometimes you work in a problem, you write so many equations, like what are we trying to achieve here, right? So we can write small t over big T, which is equal to R, right? So this is R. Okay. So big T, small t divided by big T. So this will be equal to be psi pi. So this is a double angle, right? Cos pi, cos alpha plus by psi pi sine alpha. Okay, you all can still see. I think so. All right. So from here, we are going to do some rearrangement with that term over there. Yeah, I do apologize. I'll write the equation again, okay? Maybe some of you can't see. So you have R is equal to sine pi over cos pi cos alpha minus sine pi sine alpha. Okay. So when you divide this by sine pi, so this will be 1 over cos alpha over tangent pi minus by, so you divide, so this will be sine pi. Okay.